All right, guys, last bit of notes for week 1. Today we're talking about 6.6b, that's powers of complex numbers, and the formula that your book gives you. Some complex number to the n is the same thing as its trig form to the n, and here's the shortcut. You can just take that absolute value or the magnitude raised to the n, and you've got cosine of n times your original theta here, plus I sine of n times your original theta again. So let's use this to find the 12th power of this complex number here. So I've already got this problem started right here. I know I'm finding the magnitude, that's the r, that's also called the absolute value, and I found that that is 2. And then I'm finding the tangent inverse of root 3 over 1. My calculator gave me negative 60. So I'm looking at, on my graph, this point would look like negative 1 up some. So we're in quadrant 2. So that's telling me this much right here is 60. So all the way across is 180. I'm going to take 180 and cut off 60. My actual directional angle is 120. Okay. So I can use this one, or I can use this information to put it into the trig form, because you can't just jump right from here to here. You got to actually find its trig form first. So I'm going to rewrite this guy as 2 cosine 120 plus I sine of 120. Now I'm going to take the shortcut right here. Oh, by the way, we're taking this to the 12th power. So I'm just going to take the length to the 12th, and then cosine of 120 times 12, which is 1,440. Plus I sine of 1,440. And I'm just going to simplify a little bit here. 2 raised to the 12th power, 4,096. Make sure you got a degree sign in there so it doesn't look like it's in radians. And we could be done, but you're usually not going to see like 1,000 degrees in something. So let's find the coterminal angle here. I'm just going to take the number, and I'm just going to start subtracting 360. So that's like going around the circle backwards and backwards and backwards until we come up with a coterminal one that seems a little nicer to look at. Oh, 360 or 0. So I could write this as this right here. Now, this is the trig form of the number. This would be a just fine answer also. But if I want to actually find what this number raised to the 12th power is, I can keep going and I can keep simplifying this. The cosine of 0, so think on a unit circle, 0 degrees is right here. The cosine is 1, and the sine is 0. So I've got 4,096 times 1 plus 0, or 0i. 0i, still just 0. So I've just got 4,096 times 1. So that means that this complex number raised to the 12th power equals this number.